The first thing I want to talk about is actually kind of more of an announcement than a review, but Natural Earth, the website that I first recommended for base maps, is back up and running. I looked at it this morning because if you can remember when we were doing our first workshop, during the demo, I tried to download a couple files off of it and it wasn't working. But now it is up and running. You can download base map layers from it. And I use Natural Earth for the majority of my base map layers, which is why I kind of plug it so often, because I think it's just a really great resource for people. And I actually want to go through and just like download a quick file so that y'all can see what it will hopefully normally look like, because it is a very strange anomaly for the website to be down like that. But nevertheless, I'm going to toggle over to Natural Earth, and from the main page, you'll be able to see that there are just like a number of different tabs for you to select from. So we're going to go to the downloads files, and you don't have to download this. This is purely just so that you can see me go through the steps pretty quickly. But once you're in Natural Earth, under the downloads files, there are these 3 different sets of data that you can work with, ranging from large to small scale. And all that is, it really just changes the resolution of your set that you're about to download. I typically go with large scale because it has the best resolution and it doesn't bog my computer down or take any more time to process. So yeah, for all those reasons, I just tend to go with large scale. And then from there, you can pick from the subset data of cultural, physical, or raster files. I've never actually used raster files off of Natural Earth. I tend to predominantly pick from cultural or physical data. And cultural, what that means by that is things that are defined based off of culture. So we have our cities, state boundaries, country boundaries, things of that nature, where physical is going to be our land masses or our water bodies. So under cultural, just to give you a quick example, we can see once it loads, there's just a variety of different base maps that you can pick from and different vector layers. The one that I like most is this admin 1 state provinces. And this is actually the file that I used to create that Gulf of Mexico state base map that everybody's kind of been working with for the series of activities and demos that we've been working on. So you just hit download and then it'll save in your downloads folder. You extract the file from the zip folder and you have your shapefile. And because we have been working with that data from this website, I'm not going to like open it up. But at least you can see the different categories for the different shapefiles that are accessible for you and can kind of see what Natural Earth typically looks like. Yeah, very exciting. Natural Earth is working again. Okay, so back to our lecture slides. Okay, so to go back to what we were talking about in our second workshop last week, a lot of what we talked about last week involved the attribute table. And the attribute table, if you can remember, is just basically a table of values associated with your point, line, or polygon layers. Because each individual point or line or polygon is going to have data associated with it, whether or not it's a name, maybe of the location that it's specifying. It could be a numerical density of some sort or a population. But all of that data associated with the layer is going to be stored in your attribute table. And there are a variety of reasons in which you would want to edit that attribute table. And the first way that you do that is by clicking on edit layer. And that's that pencil icon that you can see. And that really just locks and unlocks the layer. So if you don't click on that pencil first, you won't be able to edit it at all. And then counter to that, when you're done editing your layer, it's important to deselect that pencil tool and save your changes. Because there are plenty of times that I've just kind of kept on moving and then completely forgot to do that and it discards my changes and then you've lost that work you've done. or vice versa. You could start manipulating your data in your attribute table, realize it's not exactly what you want to do, and then when it asks if you want to save your changes, you just say no. So that edit layer button is very critical for changing and editing your attribute table. Then we have our add and delete attribute buttons. That's that yellow and red on the right. And those add columns in your attribute table. So you can add new values in which to associate with the entire layer. Another way that you can add an attribute column is by using the field calculator. And then that's what that image is on the right. So here we can see an image of creating a new field. We've named the field area and then specified the field type as a decimal number. And if you can remember, for field types, we have decimal numbers, real numbers, and text. And those are typically going to be the 3 types of fields that you work with. And then you can specify the output field length. And then that's just how many numbers that column is going to store for you. And lastly, if you have a decimal number, precision is just the number of spaces out from the decimal point. So once you've specified all of that information about your new attribute type, you can then write your expression for what you're trying to calculate in the field calculator. For this example, we're calculating area. So for just like a really basic equation, it's just $area. And under output preview, you can see that there was a numerical response. So that looks good. That's always a good check to make sure that you're getting the output that you expect. And then you'd click OK, and that entire attribute would show up for the whole layer. The next thing that we talked about last week was how to use the join function. And joins will occur within the layer properties of the layer that you want to join your information to. And really the only thing to remember about joins is that you need an identical attribute between both layers that you're trying to merge together, because that's how Q is going to have that link between the two. And we used the state names for our 2 identical attribute columns. So it doesn't have to be exactly like a numerical ID. It just has to be some value in which you know it's identical for each point in the layer, and that both layers have that same information to pull from. So as long as you have one attribute column that is the same for both, you'll be fine. Joins are especially useful when you are trying to join information to a geospatial like layer. So if you have one layer that is already in your map and you're trying to add more data into that layer, like an Excel file, that's a really great way to add that more information to your already georeferenced layer. And I'll talk about that a little bit later on too, so don't like get too hung up if that doesn't make a ton of sense or if I'm not explaining that perfectly clear. But we'll circle back to that thought a couple slides down. And then lastly, we talked about sorting through information and how to really like get through all of the data stored in our attribute table. And the main way to do that is using field filters, where you can select one specific attribute type and say you only want to look at fields that have the state name Florida, or you want to look at fields that only have a population greater than 500,000. That would be where you could specify those types of boundaries or conditions and sort through your data that way. Now, sorting in field filter is going to be different than using a query, because field filters are done in your attribute table itself and are used more for selection, where queries are going to be done in the layer property itself. And while the trimming of data and like sorting through information is the same, the difference between a query is that it almost basically hides that data that you don't want to see. So if you completely remove the data within the query, basically you're like trimming your layer at that point. So you put in whatever condition or statement that you want to use for your query. It will trim the data from your layer, and then it will also lock your layer, because you no longer can see. So for example, if we're only concerned with information from Florida, we put that in as our query statement where state is only equal to Florida. All of our other states will now go away, and that also locks our layer, so we can no longer add or delete attribute tables. We can no longer go into our field calculator. But the way to work around that is we then just simply save that layer, and it will create a completely new layer that only has values for Florida in it. So queries are a little bit more rigid way in which to completely like cut out the information that we're only focused on. Where sorting, that data will still be there, it's always present. And when we process the data, it will still be there and included. Where with queries, they're completely cutting that information out. And when we save that as a new layer, it won't have all of that extraneous information associated with it. So we can only focus on the data that we're interested in. And then lastly, we had a question last time that was about null values and what exactly their weight is when being used in calculations. And so I just wanted to re-go over that because that was a great question. So null values are indeed excluded in calculations. So it's important that if you have a table and it is listed as a null, don't just assume that it will run it as a 0 because that's not what Q does. By default, it will completely exclude that value. So if you run into that problem that you have a column and you have just a number of null attributes where really you want a 0 and it becomes tedious in which to go through and just put 0 in all of these, or you want to make sure like for certain that all of the null values have been transferred over to zeros. I wrote a line of code here that you would type into your field calculator to make that change from null to 0. So all this line of code is a simple if statement, and it is if field name. So you would, in quotations, write whatever field name you're interested in. So in this case, it would be test2 in quotations is null, and then comma 0, comma, and then your field name again. And underneath that, I kind of wrote out what exactly that if statement means. So it's basically if some test. So in this case, our test is if our field is equal to null, and then value of true. So if our field value, or if our field is indeed null, put that as a 0 instead. And then if it's false, if that field is not null, just keep it the way it is. Keep it as whatever field value it is. It's very similar to the layout of like an Excel if statement. So if you're familiar with that, it's pretty much the exact same. But yeah, so that is one way to kind of work around that sort of problem. And then also just something to be aware of when you're running calculations, that nulls and zeros are indeed not the same thing. And lastly, just to kind of be able to visually show you the differences on that same data set with just like 6 values on each, I ran the statistics tool on each of them. And you can see that the count for each of these is different. On the test, it has all 6, where with 5, it excludes the null, so it's just 5. And then subsequently, a lot of our values are changing based off of like our mean, our median, and just all of our values are going to be different because there's a different n value for each. But yeah, so just to drive that point in just a little bit further, and yeah. So that pretty much wraps up everything from our last workshop that we covered and moves us towards geospatial processing. So this is kind of like the meat and potatoes of we've uploaded our layers, we have data in Q, now it's time to manipulate that information a little bit and start doing some general processing. So the main topics that we're going to be covering today really fall under 2 main categories. We have our processing toolbox and we have our plugins. And under both of these, basically like packages, we have a number of different tools at our disposal. And we're going to be going over a handful of tools. However, we're really just scratching the surface of the number of tools and basically like items at your disposal to work with in Q. So realize we're scratching the surface, but I'm trying to show you the majority of the most common ones that I use all the time and the ones that I feel like are most applicable to the most situations. So hopefully this at least gives you a foundation of understanding how the tools work. And if you want to learn new tools, you'll feel a little bit more confident in doing so. Okay, so first we're going to talk about the processing toolbox. So the processing toolbox first can be found under processing, the like header processing, and then toolbox, or through the shortcut Control-Alt-T. Again, if you don't see the processing toolbox when you do either of these things, you might have to just simply like go under your manage and install plugins and make sure that box is checked next to Toolbox. I went over that in the first workshop. So if for whatever reason you get into your GIS program and you don't see the toolbox, you can just raise your hand and I can walk you through that again. But yeah. And then also keep in mind that the processing toolbox, I really do like the idea of it just being a toolbox full of tools at your disposal for different scenarios and problems that you're trying to solve. So with that in mind, as you get better at kind of working through the toolbox and understanding the different capacity for these tools, right now we're going to teach you like individual tools that you'll be able to search for by name and know exactly what they are before you use them. But I'm kind of at the point where if you know enough keywords in like QGIS jargon, you can almost just search for a task and you might find a tool that does exactly what you're looking for. So whenever I'm stumped on something, I sometimes just search through the toolbox and kind of see what's laying around at my disposal. So the toolbox is just a really great group of tools that are already pre-plugged into your QGIS software when you download it. And then in the bottom right-hand corner, this is a diagram of your basic like outlay for your toolbox. So you're going to have your input on the left-hand side of the screen, where it'll ask you to either select the layer that you want to manipulate or specify the attribute column that you're interested in. And then on the right-hand side of the window is typically going to be your description of the tool. And this description is normally super in-depth and will cover absolutely everything about that tool that you could want to know. It'll tell you what exactly that tool does, what it expects for an input, and what it will give you as an output. So what's really great about that is if you really understand what you're putting into the tool, you can be confident about what's coming out. So yeah, I love the descriptions. I think they're really useful. And because they're so in-depth, it makes learning new tools all the more easy and all the more like possible. And then you have the run button in the bottom right-hand corner. So this is your general diagram and overview of the tools in your toolbox. So with all of that being said, let's dive into our first tool. The first tool we're going to be talking about is Select by Location. This is a great tool that allows you to easily select and sort through multiple features within 2 layers. So basically what you do is, if you can look at the image of the tool on the right-hand side of the screen, you first put in your layer that you're interested in. So your select features from a certain layer, and then you select features from that layer that either intersect, touch, overlap, contain, etc., with another layer. So it requires 2 layers for your input. And then the output is simply, it will select those values in that layer of interest. So an example and a idea of what that would look like is, so for my thesis project, I actually just recently ran this tool because I had soil types for my county in Tennessee that I was interested in, but I only needed my soil types for my watershed. I didn't need it for the entire county. So I was able to put in my soils layer as my select features from, and then intersect for my where the features, and then the output layer is going to be my watershed polygon. And that then gave me that kind of cookie cutter slice of the soils that were within my watershed that I was interested in specifically. And because I had that cut out the way I did, that allowed me to then say, oh, okay, well, this amount of soil type is at my field site, and I'm then able to like calculate my curve number based off of those values. But understanding the areas of these different soil types only within my watershed was really critical. So that'd be like an example of using this tool to kind of almost, yeah, cookie cutter out that, that slice of information that you're interested in within another layer. And really what the Select by Location tool allows you to do is start to answer very basic geospatial questions. And then I have this other kind of silly example of, say you had, or you were interested in seeing if Taco Bells do better in college towns than normal towns. Well, you'd be able to answer that question, right? If you had a layer that simply had the city distribution and whether or not they are or are not college towns. And if you had another layer that had the location and maybe even gross revenue of Taco Bells in the other one. And if you had these two either intersect or cross with one another, then you could start to say, well, there are more instances of Taco Bells being located in college towns or intersecting with college towns than without. And so you can start to answer these kind of like basic geospatial questions just simply by looking at the location and intersection of these different layers. Another set of tools that I have listed on the notes of this slide, and I know everybody's going to get access to these slides, so when you're like kind of going back through them, or if you go back through them, you can go under geoprocessing tools, so it'd be vector geoprocessing tools, and they do a very similar set of processing to this function. So the only difference is this isn't really a tool, this is just a like an add-on to GIS. It's something that comes inherently with Q, and it allows you to take this select by location just a step further. So instead of just selecting the area of interest that you're trying to get to, this would instead say, if you have two layers that overlap, it would join the two layers together and make one larger polygon. Or it could also do the opposite of that. If you have two layers that are overlapping, you could cut the one to where it overlaps so that now you have two separate polygons that perfectly sit into one another. But those tools, the geoprocessing tools, do operate very similarly to the select by location tool, which is why I feel like it's worth noting here. The next tool that I'm going to talk about is the merge vector layers tool. This is a way to combine multiple vector layers. It's kind of similar to the join function, but the difference between the join function and this merge is going to be that you don't need an identical attribute column in order to make it run and work. Instead, and the reason why you need that identical column is because, like I was trying to kind of explain before, is you don't necessarily need it both layers to be vector layers when you're using a join. You could join information from just an Excel table to a vector layer, and that's fine for a join. As long as those ID columns are the same, it doesn't matter what type of data it is. However, with vector layers, these need to be two shape files that you're merging together. And because of that, because they're both geospatially referenced, Q can just combine them all together, because really what you're doing, if you can imagine the attribute table, you're just adding rows to the attribute table. So it doesn't matter if the ID columns are the same, because you're not matching by columns, you're just adding rows. And then the only other thing I want to talk about with this merge vector layer is that its default is going to be to create a temporary layer. I mentioned this in the demo last time, but most tools, if they output another like unique layer, their default most likely isn't going to save that layer. You're going to have to click on the three dots and select where you want it to save on your computer. Otherwise, when you're done running the tool and you exit out of Q, you will have lost that file. So definitely it's good practice to just continue to save whatever output that you have from these processing tools. And yeah, the only way to do that is hit those 3 points and specify where you want it to save in your computer. Okay, the next tool is basic statistics for fields. This tool will give you a almost identical output to that of when we just go under like vector and run like basic stats. It's pretty much the exact same manipulation and the same output. Really, the only difference is that this is found in the toolbox, and earlier when we were talking, that's just found in the software itself in Q. So that just wasn't in the toolbox. But like I said before, there are probably 3 different ways to do the same task, like almost any task in Q. So it's not super surprising that there are multiple ways to run kind of this same set of basic statistics. But if you want to do that in the toolbox, you just simply search for basic statistics for fields. You input the layer of interest, and you also select the field that you want to calculate your statistics on. So for this example, what you're seeing is the Gulf of Mexico states file was the input layer, and the field I calculated the statistics on was the population column. And so then this would be your output, where it gives you the count, max, min, median, and you've seen this output before. But the only other thing I really want to talk about for this like statistics is that this doesn't exactly replace like running R or doing higher level statistical analysis, right? But it does give you an idea of what's going on with your layer of interest. So I think when you're using this tool specifically, it's really great for giving you an idea of what's going on, but I don't think it's necessarily like that end all last line of statistics that you're probably going to use. But it operates really quickly, and it can give you a really decent like baseline of what's happening. Okay, the next tool that we're going to discuss is using bounding boxes. This is actually a really useful tool, and one that I really just stumbled upon. So what you do is you just simply input your polygon layer of interest, and its output is going to be this box around your polygon. And at first you could probably think like, why would you need to have a box around your polygons? Like, what information does that tell you? But the reason why that's useful is that your box layer is going to be full of attributes that are difficult to calculate or to find in your polygon layer. And what I mean by that is it will give you the width, the height, the area, and the perimeter of these boxes that correspond to a specific polygon. And there really isn't a great way to calculate the width or height of a polygon. So if you have multiple polygons that are irregular shapes, and those could represent field sites, and you want to have an idea of what the average width of field site is across your entire sample, then this would be the way you would do that. You would create bounding boxes for all of your polygons, and then just calculate the average box that you have using that statistical tool that we just talked about. So bounding boxes are surprisingly useful. And again, their main default is going to be just creating a temporary layer. So make sure that when you have that output, that you're saving it onto your computer somewhere else that you know you'll be able to find it later. The next tool is bar plot. Bar plot simply just you input a layer and it will output a bar graph of your information or data. So for this example, the input layer was the Gulf of Mexico state file. The category name was just your state name, and then value field was population. So this then output a bar graph of the different states and their populations in millions. Again, this probably doesn't substitute, like this wouldn't be found in a manuscript or like in your final paper, but it gives you that really good baseline understanding and quick check of just understanding where spatially things are happening and occurring. So it kind of puts you further down the rabbit hole, but it might not be your last output. Okay, and then we have points to path. So points to path is probably one of the most useful tools that I've found. And what it does is it takes your point layer and converts it to a line layer. And the reason why that's useful is that when you're doing surveying, I'd say most of the time, if you're doing like TopCon topographic surveying, if you're doing any type of just like general fieldwork surveying, just with like elevation points, or say you have like drone data, most of the time that output is going to be as a point layer. And just because the output's a point layer doesn't necessarily mean that that's like your final goal, right? If that could be, those points could be covering coastlines, they could be covering boundary lines for plots for your different experimental setups. So it's really useful to be able to convert these points that you've probably gathered out in the field and then take that either into lines or then going a step further and creating your polygons from those point layers. Now, the way you operate points to path is that you put in your point layer, that's pretty straightforward, and then you have your order field. Your order field tells Q the order in which it will connect the dots, basically. So then the other really useful option with this tool is that you also have a group field. So that would be if you don't necessarily want one large continuous line. So if you are eventually trying to get it to be polygons instead of like one straight line, then you would group your data points in some attribute that you would create, and it will then output in these patches of lines. So you can see an example of that below on the bottom right-hand side of the screen. So we have this group column where I have 3 data points in group 1, 2, and 3. And then I also have my ID values that I used in which to order how Q is going to be connecting these data points. And then for the output, you can see group 1, 2, and 3 aren't connected together. They're just 3 separate line layers. So definitely super useful. And then I think this is the last tool in the toolbox anyway that we're going to talk about. You have the contour tool. And this will take your raster layer, which again, you probably gather from either drone or satellite data. And that would be with your .tiff extension most of the time. So you take your raster and it will output contour lines. And the only real manipulation or like input that it asks for besides the raster is the interval between your contour lines. So here the default is typically going to be 10 meters. It's important to kind of keep in mind too that like the size of your plot or your area of interest is going to severely impact your interval between contour lines. Or in other words, I've used 10 meters and then done that across an entire state. And obviously that's going to take a very long time to process. So just like keep in mind that the smaller your contour interval, the longer it's going to take to process. But that's pretty self-explanatory. And then you also get a set of attributes associated with each of your contour lines, because your contours are most likely going to be setting up a elevation in space. So that attribute will have an elevation value. And I typically just name that attribute capital ELEV, but you can name it whatever you want. That will remind you that it's most likely going to be elevation associated with each of those contour lines. And then in the bottom left-hand side of the screen, this is actually from my thesis work again. I used my surveying data to create a raster in AutoCAD Civil 3D. So that's that raster on the bottom left-hand side. And then I took that raster and brought it into Q and created my contour lines from that so that I could further process that data later on. And so like basically what you're seeing here is that this is like my stormwater outfall, that like U-shaped item in the upper hand side. And then we have that kind of stormwater flow path cutting through my site. So that concludes our toolboxes and our tools in our toolbox. Now we're going to kind of shift gears into plugins. They're pretty similar to that of the toolbox. The only difference is that plugins are specifically written by the QGIS community themselves, which I think is part of like one of the really great things about Q is that there's always new plugins and there's always new tools being added. The toolbox is typically going to be set by the people that actually like put out the QGIS software, but plugins, anyone can write a plugin, and as long as it's been tested and kind of proves it does what it says it does, it can appear in everybody's version of Q. It'll be in that plugin installer. And so to find your plugins, all you have to do is go under the actual tab plugins and then manage and install. And from there, you can search through a huge database of the different plugins that are currently available, have previously been available. And the only other type of plugin that I kind of want to talk about is it'll show you the ones that you've currently downloaded or installed on your computer, but you can also look at invalid plugins. So that's that fourth from the top tab on the left-hand side of the screen. And invalid plugins are interesting because those are basically plugins that used to be available, but have been proven to have enough bugs or enough like errors to kind of be pulled off of the general like platform. And so basically it's Q's way of saying like, this doesn't actually work as well as we thought it did. Like tread lightly if you use it, or it's just completely broken. There's some type of bug that needs to be fixed. Because there's been times in the past that I will be using a plugin for a long while, and then all of a sudden that plugin will disappear and I'll find it in that invalid plugin folder. So there was some kind of critical bug or feature glitch. But it is interesting and I think exciting on a lot of fronts that we have this database of like community tools that are constantly being edited and created. And the two main types of plugins that we're actually going to be focusing on are the Georeferencer plugin and QConsolidate. And then the only other thing to talk about is that when you install a plugin, typically what's going to happen, at least for the older versions of Q, you would install a plugin and then you'd have to restart QGIS, so just completely close out and reopen for it to show up. I think with the newer versions of Q, you don't have to do that anymore. I think as soon as you download it, it's available. But if for whatever reason you do download that plugin and it's not there, you can try just restarting your Q software window. Okay, so the Georeferencer plugin. This is probably the most used plugin that I use. And it's actually kind of interesting because it used to be found in the manage and install plugins database, but I think because of how much traffic it's seen and how long it's been a plugin, it's now one of like the core tools that are just downloaded with Q. So it's kind of made its way out of the plugin like window database and just into the QGIS software itself. So you shouldn't have to actually go under manage and install plugins to find the Georeferencer anymore. At least that's my understanding. So definitely let me know if you can't find it, but we're going to walk through an example of using it in the demo. So just kind of keep that in mind that this is actually, I'm pretty sure, a plugin that has kind of upgraded itself from being a plugin to just always being in Q's software code. So what you do with the Georeferencer is it allows you to take an image that would originally have no way of being like spatially referenced and bringing it into your map plane. So you could take a screenshot, for example, from Google Earth's and then gather coordinates from that screenshot of areas that are like really well known and be able to bring that in, tell Q, these are the data points that I know where it's located on that image, and then specify some different settings for how you want the image to be brought into Q, which we'll walk through step by step. Then you set your coordinate reference system, you set your name of where you want that layer to save and what you want it to be called, and then it'll bring that image in. So it's really useful for basically referencing that image in geospatial space and bringing it into your map space. So this allows you to not only have like more defined or clear base maps, but yeah, you can then kind of take this a step further and say, if you have this Google Maps screenshot, that you could then create layers that trace different elements from that map that you may not have had access to otherwise. So an image can give you access to a lot of data that you could then create layers in which to like manipulate or calculate like features off of afterwards. Before I move on, let me make sure there aren't any questions, just because this is kind of like a good pause point. Okay, so I don't think I see any like questions of immediate concern. Seems like most of them.
Real quick, answer Farah's questions about explaining the difference between intersect and cross and overlap, or maybe we could keep that for the demonstration if you're planning on doing something similar then.
Yeah, we can definitely do that. Honestly, with those types of like descriptions, I tend to just quickly Google them right before I use them because they are so similar in like verbiage. But what we can, I can bring that up back in the demo. So just kind of like remind me when I'm like going through everything that we can go back through those specifically. But yeah, that is a really good question. And yeah, so it does sound like Georeferencer is already a part of your QGIS download because it is a core plugin now. So you don't have to download it, but it used to be you had to. But that's no longer the case because it's been tried and true and tested. So cool. But yeah, I will go back through what the difference between like intersect and overlap are in the demo. Okay, so going back to that georeferencer, so when we have our different data points that we have specified in our image, and we tell Q, okay, so we know where these 4 data points are. Q then has to make some amount of assumptions for us in order to actually bring that into our map space. Because just because we have 4 points, it has a lot of other data points that it needs to try to figure out where exactly they should go and where they should rest. So you then select your transformation type, and you have linear, Helmert, polynomial, thin plate spline, or projective. And this is just coming from the QGIS manual. This is just like a screenshot from that website that goes through and explains what exactly is going on with each of those. So I'm not going to talk through each and every single one of these. I'll just kind of like mention that thin plate spline is the one I tend to use. I think it's like the most robust one. And as it says, it's useful for very low quality originals, which when you're working with Google Maps, kind of get what you can get from Google Maps. It's not always the best. So also I just find it to be, like I said, very robust and easy to work with. There has been a point in time that I can remember I went and used every single different type of transformation and looked at like how that changed my image being brought in. And I didn't see huge amounts of differences between the like 5 different ones. So kind of also take that in mind, like that it's probably not the end of the world if you pick the wrong one, or like it's kind of almost difficult to know which one is most appropriate, but you can read through these a little bit more when it comes time for you to select what type of transformation might be most appropriate for what you're working on. Okay. Next is the image that we're going to georeference for our third demo. So I just want to talk you through what exactly this is and why I picked the points I picked. So this screenshot is actually from Weeks Bay, Alabama. And basically what I've gone ahead and done is selected 5 points on this map that I'm going to use as my georeference points. And so I've already gone through and created this table of latitude and longitudinal coordinates. And I think I've talked about this before, but when you're in Google Maps, you can just right click on a point and it will pop up what that latitude and longitude is. So I've already gone through and written out the coordinates for each of them. And the reason why I've picked these points in particular are, one, because they cover nearly every corner of the map that I'm interested in. So it's really important that when you're trying to select these points, that they're not all clustered up together in one part of the map or right in the center, because that will allow Q to have to make more assumptions on your behalf. And that's what we're trying to avoid. So if you can keep your points really well spread out across the image, that way it's having to assume less for you. And then when it's starting to do its transformation, it won't seem as distorted because it has a good idea of where it's at. And then the second thing is that when you're working with Google Map images in particular, just any data point, you're going to want to pick something that you know you can go back to relatively easily. So here, like point 1 is at a pretty large intersection. So that like 90-degree bend on that yellow road is pretty easy for me to identify. The same with point 2. That's right at the like edge of the Weeks Bay Bay. And then you also have just a couple more like corners of intersections where road hits a stream. And so you just don't want to pick somewhere kind of arbitrarily like in the middle of this gray tan space and get kind of in the right ballpark, you want to make sure that it's like fairly on top of the target that you're hoping to hit. So you want to make sure it's just really easy to go back to and see again. And then this is the last plugin that we're going to talk about, and this is QConsolidate. And probably by far, this is the most used plugin that I use, and I'm going to pitch it to you in this way. Basically, what it does is it will create a zip folder of everything in your project that you're working on currently. And I think the most straightforward thought is that it's really convenient for uploading and sending and saving data. So if you have a project that you're working on and you're looking to send it to someone else in your group, it's really easy to just use QConsolidate and just write your name of your project that you're working on, select where you want it to save in your computer, and that entire project will be bundled up into a perfect zip file folder. The more, I think, less obvious pro of using QConsolidate is that when I'm working on a project in Q, I try to keep myself as well organized as I can and like have those file folders where I pull all of my data out of the same place, but almost inevitably, I'm pulling files from my downloads folder, I'm pulling files from my desktop, and by the end of a project, I have files just scattered about my computer. And the thing about Q is, say I was using a base map that was in my downloads folder. If I move that base map out of my downloads folder, the next time I pull up that project, Q won't know where to look for that base map anymore because it's not there. It's not in the downloads folder where it's been told it should be located. But if you use QConsolidate, it will take all of your associated files, so all of the layers associated with your project, and put it in that file folder. So I'm trying to get better about when I'm done with a project, just running QConsolidate and tying that project up into one nice package and then leaving it somewhere in like my documents folder or somewhere else that when I go to access it, I know everything associated with that project is there. That way I don't have to worry about like just files thrown about my computer in my desktop or in my downloads folder that have to stay there forever because my QGIS project references them. So QConsolidate, it's a lifesaver. I definitely recommend it. And it has just a ton of different uses. And then lastly, the only other thing I want to talk about plugins is that because Q is so like robust and it's open source, it allows you to be able to create your own plugins if you want. So if you have a background in Python, you have the ability to really create and process your own information in whatever way you could really think up. So you're able to be really creative in that way. And the way you get to your Python console is just simply, you can either pull it up under View, Toolbars, Digitizing Toolbar, and you should see the Python console pop up there. Or you can go under Control-Alt-P, and that Python console window should pop up. And then I've never actually personally used the Python console, so I'm not like super knowledgeable on it, but I do have the GIS manual as well as a like kind of introductory YouTube video on it. So if that's something you're interested in or something that you feel confident in Python and that you could probably apply it to Q, definitely like take the reins, you know? So there's a lot of freedom in Q, and I think that's one of its biggest like advantages. Okay, so that leads us to our demo 3. So in demo 3, what we're going to do is import the demo 3 image, which is going to be that Weeks Bay photo that I was talking about earlier in the lecture. And we're going to go ahead and georeference it and bring it into our map view. Then what we're going to do is kind of more arbitrarily, we're going to create a point layer, fill it with attributes, and then run it through the points to path tool. So we're going to create a point layer, convert it to a line layer. Then we're going to take that line layer, convert it to a polygon layer. And from there, we can just fill it with a couple attributes, run statistics on it. And the last thing we're going to do is run through that bar plot and recreate that image of the bar plot for the Gulf of Mexico states population. So we're going to be using the Georeferencer plugin, a variety of different plugins for the layer types by going from points to lines to polygons. And then lastly, we're going to be using that bar plot tool. So that'll give us a pretty good array of tools that we're kind of pulling from and referencing. Okay, so let me kind of get out of the presentation mode. Make sure. Okay. So going into Q, we are going to open up our QGIS window and start a new project. Then what we're going to do is I'm going to pull in the Gulf of Mexico states layer just so that we can have it for like our own reference. So I'm just going under layer, add vector layer. And once again, pretty quickly, just going into where our Gulf of Mexico state file is listed and bringing it in. So add. Okay, so once you have your Gulf of Mexico states file added.
Hey, Jill. Sorry to interrupt you. We can't see your QGIS screen. We just see the presentation.
Oh, perfect. Let me stop share and try again. We good now?
Yes.
Cool. Okay, so all I've done is bring in the Gulf of Mexico states file. The first task that we're going to walk through together is using that Georeferencer plugin. So the way we're going to access that is just simply under raster and then Georeferencer. And from this window, we can pull in that JPEG image that I was talking about earlier using Open Raster. And it will ask for that location of that image. So I have my demo 3 just pulled up here on my desktop. So we click open and then here it is. So now our task is adding these reference points to the image itself. So that's using this add point tool. And the very first point is going to be here on the left-hand side of the screen where this bend in the road occurs. So I'm going to select this point. And then for my X and Y coordinates, we're going to kind of be toggling back and forth between the slides and the GIS window. So let me pull up this table. And so this first point is corresponding with this row here. So I'm going to just go ahead and copy this number over. I don't know if there is an easy way to just take a picture of this table and drop it in the chat window. Is that easy? Or like, is that possible? Just so that you all can kind of see it even when I'm not there. Let's see if that.
I don't know if we can put JPEGs in the chat.
Yeah, I'm not sure either. No. Yeah, I don't think I can.
Here, I'll write them in the chat, Jill, so that folks can get them. So you can do anything.
Sweet. Okay, so I'm gonna go through this first one. So I grabbed the north value first. The north value is going to correspond with the Y. So you just paste. And then your west value corresponds with the X values. And once you have that data point in, you just click OK. And now you see that red point pop up on your screen. Next, what you're going to do is move on to your second one. So this is kind of like the more tedious of actions. So you're just going to add in the other 3 remaining points. So you just kind of toggle back and forth. And once I get to the fifth one, I'll describe how to grab a data point from the map itself. Okay, so I know I kind of ran through that pretty quickly, but just so that y'all can kind of see, I have the 4 data points in. For the 5th point, that is going to be located at this peak here. And so when I select that on this image here, you have the ability to select from map canvas. So what that does is it brings us back to our map view, and we can then select where in this space should be referenced to that image. So basically we're getting our latitude, longitude from our map view itself instead of just from a latitude, longitude listed in Google Maps or Google Earth. So if you kind of zoom in a little bit, you can see the 4 data points that are already selected. So we at least know we're on the right track. And then if we zoom in just a little bit further, here's that same point in our map view. So this is also kind of the benefit of just having that general base map uploaded. So we select that point and it'll automatically fill in the data points or the numerical latitude and longitude. And we click OK. And now we have all 5 of our georeference points. So from there, we can go into transformation settings. Let me make sure in the chat that everyone's good, just because that was pretty quick. Okay, so you have those data points in the chat from Sarah. So you can just kind of slowly work your way through that. Once you have your data points in, you click on that yellow wheel icon. That's your transformation settings. From there, you can select your transformation type, which, like I said, I tend to use thin plate spline. For resampling method, nearest neighbor is fine. That's the one I normally go with. It's pretty default. And then for target SRS, that's going to be WGS84. That's what matches our coordinate reference system for our project. And then lastly, we have our output raster. So the output raster is going to be saved just on my desktop as demo3 modified. And that's going to be as a .tiff file, which is fine. So we can save that. The only other thing to really note is that there's this box here that says loading QGIS when done. I definitely feel like when you can have it just loading GIS, it's just easier to immediately see it versus trying to search for it in your computer right after you run it. So check that and then click OK. Now the only other thing left to do is click run. So that's that green arrow in the upper left corner. So you just click start and it'll think for a second. And then when you look at your map, the image of the demo3 file will be right over where your base map is. And you can see kind of the edges where it started to transform a little bit in order to fit the base map itself, because screenshot from Google Earth is not going to match the coordinate reference system or like match your base map exactly. That's kind of the point of Q going in and kind of tweaking and making sure everything is set roughly where it should be. The only other thing I want to kind of show you with this is I'm going to bring it underneath my layer and then double click on my Gulf of Mexico states layer and just drop the opacity down to 50%, just so that you can see kind of how these two things match up and how it's pretty good for what it is. And from here, if you had a field site, you could go back in using this image and kind of create a more kind of not contoured, but a little bit more detailed coastline than what this natural earth base map is giving you. So it allows you to now be able to do a number of different things with this image. Because even if you brought in this image and you were interested in a field site between 2 roads, you could create a polygon outlining this area and then run an attribute, a field calculator on it and figure out what the area of that space is. So this is kind of a long-winded way of saying that once you have your image in, that image has associated information with it. Typically, it's going to be visual information that you can then bring in and create layers and process in that way. So if you have any issues with your georeferencer, definitely just type it in the chat and we can kind of work through those as they come up. The other thing I wanted to kind of show you guys was under vector and geoprocessing tools. This is where, this is what I was talking about when I was talking on the selection tools in the toolbox. So these are like the accessory tools that allow you to do a little bit more like processing, where it will clip between two layers, or it will dissolve two layers into one. There's just like a number of different features underneath the geoprocessing tools that I feel like are really useful, especially when you're working with multiple vector layers. But just kind of more for your own reference to know that they're there and that they're able to be used. The transformation type is going to be thin plate spline. Yeah. And then let's run into the selection tool just so that we can talk about the differences between the different types of selection tools, just so that while people are kind of like plugging in that north and west in their georeferencer, that we can talk about something else before I move on. So let me go to select by location. Let's see if so within the select by location window, what I was trying to see is if it gives you any other information just from the window itself, and it doesn't. Another great place that you can just go to is just Google it. And normally the documentation on a tool is pretty extensive, so it'll tell you exactly what each of those things are meant for and used for. Let's try one more before I kind of say I'm not quite sure, but maybe I'll cover it in next time. Yeah, okay, so it's looking like in order to describe like what the difference between intersect, touch, overlap, and like cross are, I'm just gonna cover that next time. Because I don't want to tell you guys the wrong thing, and I can't quite find something just easily pulled up right now. But that's definitely a good question, and it's good to fully understand how that plugin works, right? So.
Hey, Joe, there's a quick question from JJ. He wants to know, can we edit the locations after we have run the, I think it's supposed to say the georeferencing tool?
Yeah. Yeah, so I do that all the time. Mostly what I do is I tend to like reverse the north and west values. So I'll put north in for my west and west in for my north, and it will completely mess everything up. The way you get around that is, so I haven't actually exited out of my georeferencer box. This is another really kind of quirky thing about this tool, is it'll just chill in the bottom left-hand side of your screen. So it'll seem like you've exited out of it, but then when you click on it to bring it back up, it won't appear, and it's because it's right here. It's still available. So if you can't find it, it's probably in the bottom left-hand side of your screen. And then from here, yes, you can edit your points. You can either, you can completely delete the point, or you can move it as well. I'd say normally, I'm trying to figure out, I think you can also just simply like double click within your table, your GCP table at the bottom, and type it out. So there are a couple different things you can do. You can either just completely delete that point and start over and create a new one. You can move that point if you want. I feel like that might be a little less useful. Or you can go under, and if you know the order in which you added your point, so that first point I added would probably be ID 0, and I can just change my destination X and Y to what they should be. So if I messed up and all of these should be over here, I can just pretty quickly copy them over. So those are the two main ways I feel like it's easiest to edit those. So either delete it, start over, or manipulate it in this table underneath. The other thing is once this is made, you can also save your like georeferenced points, so these GCP points themselves. So when you like exit out, it'll ask you if you want to save them. And that's what's really great about doing it, is if you've messed up or if you need to edit them in the like future, when you pull up this image, you'll have this GCP table that allows you to kind of go through and more readily like manipulate that information. So it's always a good idea to save it. But yeah, that's a good question. Okay. Okay, so I'm going to move on to creating our point layer and start walking through how we're going to create our points and then bring that point layer into a line layer. So the first thing we're going to do is just create a blank point layer. So we've talked through that before. That's just layer, create layer, and then new shapefile layer. From there, you specify your name, which I'm going to name this one Demo 3, and save it. The geometry type is going to be point. And then WGS 84 being the coordinate reference system is fine. The only other thing I want to do here is I want to add a field called group because I will want to group these points together. And that will be a whole number because I plan to have all of my groups be based off of whole number values. And make sure you hit add to lists or add to fields list. It'll drop down here. So now you have 2 attributes in your attribute table, and click OK. So now we have this blank point layer with nothing in it. And we're going to add to it by simply selecting it so that it's blue in the layers window. Then we're going to edit it. So toggle editing, that pencil that I talked about before. And we're going to fill it with other point features. So just hit add point feature. So from here on out, this is going to be a little bit more arbitrary. Again, if you had a referenced image that like references back to your field site or area of interest, then we could like trace along that that boundary condition or that site. But for what we're doing here, we're just kind of working through the mechanics of these tools. So it won't really matter what shape or order in which you add these points. It's more about just doing them and running through the tools themselves. So I'm going to first make, like I said, just an arbitrary box out of points. And the ID values are going to be 1 through 4. And the group is going to be labeled 1. This is going to be my first, basically, polygon I'm going to create. And where I put them in space doesn't really matter. But it could, which is the cool part about georeferencing an image. Okay, so these are IDs 1 through 4. They make a box, and all of their group values are 1. Beside that, I'm going to make a triangle, again, completely arbitrary. And this is going to be ID values 5 through 7. And that's going to be group 2. So ID 5, group 2. Okay. The only other one I want to make is going to be, I guess we can do some type of trapezoidal circular shape. And that'll be another 4 data points, and that'll be group 3. So starting with ID 8, 3. So I've now created this just a array of points in my layer. They all have different ID values, which is going to tell the tool the order in which I want them to be connected to one another. And then they also have group values, which will tell the toolbox when one line should end and the next line should begin. So we're going to click toggle editing to kind of freeze that layer because we're done editing and changing it. We'll save these changes. So now that it's been kind of locked, there's no more editing going on. And then this is where we run into the processing toolbox. Like I said, I tend to keep it on the right-hand side of my screen. I'm just going to search for points to line, or points to path, excuse me. So I'm going to double click on points to path once it pops up. And it's going to ask for an input point layer, which is going to be demo 3. The order field is going to be that ID attribute that we just created. And then the group value is going to be group. And for this demo, I'm fine with all of the temporary layers staying temporary, but if I didn't want that, I would just select beside it and save to file. That's easy enough. Then what we're going to do is hit run. And here you can see 3 separate lines that have been created. And in my layers panel, we now have a new layer, a line layer called paths. So what's cool about this is we can go into the attribute table and then run a field calculator to tell us the lengths of these lines if we wanted. So if these lines correlated to some length that we were interested in, we could very quickly gather that for ourselves. The next thing that we're going to do now that we have these lines is create polygons from them. So the way to do that is in the toolbox. Again, you're just going to search for lines to polygons. Mine's in recently used, but if you keep typing, you should find it under vector geometry. So again, just double click on that tool that you're interested in. The input layer is going to be paths. That's that temporary line layer we just created. And then again, I'm fine with this polygon output being a temporary layer. So we're just going to click run again. And so now we have effectively filled in these shapes and created shapes out of those lines that we had. And the difference between line layers and polygon layers, obviously there are a ton, but when it comes to our field calculator, now we can calculate the area of these 3 individual shapes. So let's go ahead and do that. The first way we'll go about doing that is you just make sure that the polygons layer is highlighted and then go under your field calculator button. So the abacus up there. Once the field calculator is open, we're creating a new field and we're going to call it area. Next, the area itself is going to be a decimal number. So we just drop down and select that. The output field length is a default of 10 and precision of 3. And then the only other thing left to do now that we've kind of specified the formatting for our attribute is to actually write the expression or write the code that will calculate the area for us. So the way we're going to do that is just $area. And as you can see in the output preview, you have this numerical output right here. So that looks great. And we click OK. And so now when we look in our attribute table, we have our group number, and there's groups 1, 2, and 3, which makes sense. Then it also has a begin and end point, which is from that line layer. That was the points that started and ended that line. And now we also have the area in squared meters, that comprises that polygon we just created. So now that we've gone ahead and done all of that, I believe the only other things or tasks left to do with this demo are to run statistics on these 3 points and then create a bar plot. So in order to run statistics on these 3 polygons, all we're going to do is go back to our toolbox and just run, just type in statistics and see what pops up. So obviously a lot pops up. Let's go under basic statistics for fields. That's probably going to be the one we're looking for. But it's also worth mentioning, like, one keyword gives you 20 different tools that you can reference and look at. And there's statistics for all different types of inputs too, right? So you even have statistics specifically for raster files. So that's pretty nifty. So I'm going to double click on basic statistics for fields. And under my input layer, I apologize for my dog being especially needy today. So excuse me. So we select our polygons as our input layer, and then field to calculate on as area, and then we just click run. So then once we've done that, so once we've set our field as area and our input layer is polygons, we can click run. And we'll see that the output from that statistical run is going to be in the bottom right-hand corner. And so when we double click on that output, it will pop up like a general HTML file and give you, there were 3 polygons. This was the max and minimum number for our area, and all the different other values for that, that calculations. So that's just generally how the statistic tool will be used. The only other tool I want to walk you through is that bar graph or that bar plot tool. And I want to run that on the Gulf of Mexico states file just so that you can see what that looks like and kind of how easy it is to perform like that bar plot. So getting out of statistics and typing in bar, we're going to double click on bar plot. And our input layer here is going to be Gulf of Mexico states. Our category name is going to be state name because I want to have my plot be per state. And then our value, it can be anything. I'm going to have it be population because I know these population values are in millions. And then that's just generally like helpful for you to understand like what attribute is of interest. So then we click run. And we will close this window. And now in this bottom right-hand corner, you should be able to see where the bar plot is being saved. So this is kind of the benefit of having the results viewer open, because now you can see where statistics was saved and then also where the bar plot was saved. So if you double click on the bar plot, it'll pull up that graph. So we have now effectively recreated that graph from the lecture. And we would know that these values on the y-axis are going to be in millions of people. And it just gives us a general idea of what's going on with our polygon layer. Yeah, so that is effectively walking through all of the different tools that I wanted to kind of talk you through. If you had a hard time hearing me through that last couple tools, like the statistics and the bar plot, I can go over them again. I think for the most part, my pup has calmed down. But yeah, that is pretty much everything I had to cover today, though. Like I said before, the results viewer is super useful just because it shows you all of the different tools you've last used and the output of all of the things that you've just recently ran. And yeah, that's pretty much everything I have for today. So unless there are further questions, I'm good.
Awesome, thanks, Jill. Any questions? Y'all can raise your hands virtually or type them in the chat. Thank you from John. Thank you, John. And Julie says thank you. So yeah, I don't think there's any questions for you, Jill.
Yeah, you guys have my email. If anything, I'll see you at our last class.
Alrighty. All right, everyone. Thank y'all. See y'all next week.